Hi and welcome to this video from Unit 4, Topic 4, Normal Distribution from Math Methods. And it's going to be quite a short video because I just want to round off the stuff that we were doing in the last video. So it's kind of a video 2 supplemental, and so naturally I'll call it video 3. And because it's going to be short, we'll start with the joke today. And I want to know, where is the best place to hide an army? And of course, the answer is in your sleevey. Anyway, moving on. Expected value and variance is something that we've talked about a lot as we've moved through this topic. We talk about it in all of our distribution work, but it turns out the expected value and variance is easiest here because we already know the values. In a normal distribution, we're working with either a provided mean and standard deviation that are related to the context and are appropriate for those raw scores, or we're talking about the standard normal distribution, in which case the expected, or the mean and the standard deviation are 0 and 1. So it's just as simple as recalling that mu, which is the mean, is actually also known as the expected value, and sigma, which is the standard deviation, is also known as the square root of the variance. So if you want to find the variance and the expected value is just equal to the mean, and the variance is equal to sigma squared. And in fact, we often say that x can be approximated by a normal distribution where this is your mean mu, but we could say it's expected value, and this is your variance x, and you take the square root to find your sigma and do your normal distribution work. The long form of this, though, is you could go back to our continuous random variables work and know that expected value is the integral between our boundaries, which in this case is infinity and negative infinity, of x times our probability distribution function, and that would be x times this. And of course you could put that in your calculator, but you will get 0 because a standard normal distribution has a mean of 0. And the variance is the same. Now we've got a mean of 0. We put in e of x squared, which is between infinity and negative infinity of x squared, f of x, where f of x is our standard normal distribution probability function. And of course we've got 0 squared there. You put it in your calculator, you get 1, 1 minus 0, you get 1. And of course we know that sigma equals 1 in the standard normal distribution. More details in the textbook if you want them. You probably don't need to know them, or you're welcome to talk to me as well. And let's just finish off this exercise by talking about example 3. Given that in a distribution x, f of x equals this thing, determine mu and sigma. Now remember that f of x is equal to 1 over sigma square root 2 pi e to the negative half x minus mu over sigma squared. So for me, this is about as hard as it gets, this particular example, because there's nothing overly obvious. But for me, I'm thinking I can work that out because it's related to this 2 somehow. And I can work that out because it's 1. And this is causing me a bit of a headache. But if I've worked out sigma down here, I can just verify it works there. Because you'll notice here there's negative 2, but this half has also vanished. So let's have a look. What needs to go there such that I end up with a 2 in the denominator? And the answer is that sigma must be a half. So the other way I could do this is I could say, well, I know that 1 over sigma has to equal 2 because I've got this, and I'm going to do multiple garish highlighting, but I've got that is equal to 2 over 1, which is just 2. You do that rearrangement and you get this. And I've got mu equals 1. And so if that's the case, it means that f of x should equal 1 over sigma 2 pi times e to the negative half times x minus mu, which is just 1 over a half squared. And if I do the expansions here, 1 over half just gives me 2 over the square root of 2 pi, so that's worked. E to the negative half times by a half squared, times by 2 squared, because we're dividing by a half, which is the same as multiplying by 2. And then I'm left with x minus 1 squared And of course that is 2 over the square root of 2 pi e to the, and that all cancels out. Negative a half times 4 is just negative 2 x minus 1 squared. And that is what we started with. So we're happy with that. Our solutions are here. And I'd obviously write it up slightly neater. Anyway, that's example 3. It means you can now move on with exercise 17a. You'll find some of the stuff we've covered isn't actually in 17a, but I just felt that you needed to know some of this stuff before you really started 17a effectively. It will make our time a lot quicker in 17b, c, and moving forward from there. All the best.